Welcome to this demonstration of the HDF5 read-only virtual file driver for Amazon AWS Simple Storage Service, or S3. In this video, we will give an overview of the HDF5 virtual file layer, show you how to use HDF5 command line tools H5ls and H5dump with the S3 VFD, and how you can easily utilize the S3 VFD in your own C programs. The ASCII graphic you see here shows the stack of abstraction between an application and the underlying storage. The application relies on the HDF5 library and its C API. The HDF5 API sits atop a virtual object layer, which allows engineers to provide an alternative implementation of the interface. For example, a RESTful vol to communicate to some exotic network mechanism, or port your own core logic to the HDF5 object model and API. The standard vol relies on the core HDF5 library, which has a virtual file layer, where our S3 VFD lives. This layer allows engineers to define non-standard mapping between the core library and various forms of storage. Virtual file drivers that come with the library include, among others, storage on POSIX or Windows file systems, a core VFD which holds objects in memory, VFDs which, for their own purposes, split a single logical file into several independent files on disk, such as to store massive files on a size-limited system. The contract of a virtual file driver means that, regardless of where the actual bytes are stored, in memory, in one file or 1000, in an object store, or some exotic file system, the HDF5 library is guaranteed a consistent representation of the file. The ROS3 VFD, that is, this read-only VFD for S3, makes use of this layer to allow read requests from HDF5 files stored as objects in a bucket on S3, sending read requests and receiving bytes via a RESTful HTTP interface. The ROS3 VFD uses libcurl to translate the HDF5 reads into HTTP requests, send these requests to S3, and receive bytes in the HTTP body and pass that data to a destination buffer for the library. Another product offered by HDF5 is a VFD that allows read-only access to files on the Hadoop Distributed File System, or HDFS, which uses libHDFS and the Java Virtual Machine to access stored data. H5ls is one of the standard tools provided along with the HDF5 library and allows users to examine the structure of HDF5 files. H5ls has been augmented to utilize the ROS3 VFD. You can see whether your copy of H5ls has this feature enabled by looking for the argument s3cred in the help message. This argument is used to pass authentication credentials to the application to access objects that do not permit anonymous access. The argument, an abbreviation of S3 credentials, takes a tuple string of 3 comma-separated elements, AWS region, access key ID, and a secret access key. S3 cred is only required when accessing restricted S3 objects, and when the VFD argument is ROS3. At this time, no provision is made to use AWS profiles stored on your machine, for example in .aws/credentials in your user's home directory. Here we have an example HDF5 file in a bucket on S3. In place of a file path as you might usually see, here it is obviously a URL. We have specified the ROS3 VFD, --VFD equals ROS3, and the recursive flag -R to show all groups and datasets in the file. Because this file permits anonymous access, we do not need to use the S3 credentials argument. Because there is only one dataset in the root group, the -R argument was somewhat unnecessary, but we see that the dataset, dset, has 3.2 million entries and has no max bounds. netcdf4 files are also HDF5 compatible, and H5ls will allow us to look at this example. We'll only grab direct children of the root group for now. Notice again that we have specified the ROS3 VFD, --VFD equals ROS3, and provided a URL to the file object in place of a file path. Now we will list items recursively from the group output, and we should expect a much longer delay between execution and termination. Because H5ls has to identify groups, then look in those child groups and so on recursively one after the other, there are many sequential REST requests being sent to S3. H5ls is now running. The file is not being downloaded. Only a small number of bytes are being transferred, but network latency and a significant number of independent requests results in a moderate delay. At last, all children of group output. H5dump is another command line tool that comes with the HDF5 library and allows you to view very detailed information about items in the file. For example, groups and datasets, attributes and data types associated with those items, and data stored in datasets. H5dump has also been augmented to utilize the ROS3 VFD, and with only one or two arguments will behave as though our file on S3 were on local storage. Because the tools are inconsistent in their arguments, with H5dump we use --file driver instead of --VFD as we did with H5ls. Without this file driver argument, H5dump will look for our file on disk and fail. H5dump does, however, use the same S3 creds argument as H5ls. We will use the arguments -P, B, H to get an overview of the file, object properties, the file superblock, and object header metadata respectively, and specify the ROS3 file driver to accompany the file URL. When we run this, it hangs for a moment, as many small metadata reads are being executed over an internet connection. Looking at dataset dset, we can see its data type has strings for date and symbol, integer for sector, and float values for open, high, low, volume, and close. Its data space, no filter, and its other metadata. A common use for H5dump is to visually inspect data stored in an HDF5 file. Here we will take the same SNP file on S3 and from dataset dset, starting at coordinate 1,234,567, select a 10-element range. Because there are many fewer read requests involved, it completes very quickly. As we might expect from the data type we looked at earlier, we can see date, open, high, low, close, etc. for each entry. It is very simple to use the S3 VFD in your existing C code. The only changes required involve preparing a file access property list, or FAPL, and passing it into your h5fopen function call. The application logic is completely unchanged after file open. This demonstration program simply gets the file size and information about the root group, all using very standard HDF5 API calls: h5f get file size, h5o get info, and h5g get info. Once we have that information, this program just prints it out. File size, location of root group, number of attributes associated with the root group, and the number of members or links in the root group. At the top, we have declared our file URL and the AWS region of the file object, a ROS3 FAPL configuration structure param, and HIDs for the FAPL and file. We create the FAPL with h5p create. In the configuration structure, we set its version. At this time, the version must be 1. And, because the file permits anonymous access, we set its authenticate value to 0. If we were authenticating, we would set authenticate to 1, and copy in our credential details. One way being, as you see here with AWS region. The 3 authentication fields are AWS region, secret ID, and secret key. Then we call h5p set FAPL ROS3 with our FAPL and configuration structure, and use the FAPL to open our URL with h5fopen. It is important to close the FAPL with h5p close before application exit, just as you close files with h5f close. When we compile and run this, the output is generated from the file on S3, with no file download taking place. To summarize, the read-only S3 VFD allows you to inexpensively and relatively quickly access HDF5 data stored on S3, transmitting only as much data as your application requires. Several HDF5 tools allow you to perform common operations reading from files on S3. Modifications in your own C code to use the S3 VFD is highly compartmentalized and requires no change to your application logic. Plans for future developments with the S3 VFD include improved performance with metadata extraction and prefetching, and eventual added write capabilities. Thank you.